Hello, welcome back to this episode. This is the part 4 or part B of part 4. The previous episode, we solved the same question using the direct formula. We code the formula, which is a long thing. We need to remember the formula. Here, we want to solve it using similarity approach without remembering the generalized formula. So we are saying that we have to calculate one, the lateral area, surface area, and the volume of a truncated cone of radii 2 centimeter and 6 centimeter, and the height is 10 centimeter, just like we have drawn here. Now, what the question is giving you, truncated cone, is a frustum. It is this one, figure 3, figure 1, 2, 3. This is the one that the question is talking about. So in the previous episode, we based our calculation only on this. Here, we want to take it a fact that a truncated cone was actually in this form before the smaller cone was cut off. So if I have that idea, what the question gave me, what cut off, if I add the 2, it would have given me the original structure. So finding this simply means taking the cone here off the original structure give us this. So we don't need to memorize any formula. We only need to know the formulas for the cone, curved surface area of a cone, total surface area of a cone, and the volume of a cone. Okay, now we know that all of these make use of slant height and the height itself. So in the case of this, we need the height of this, which we don't have. Here, we also need the slant height, which is this. We don't have. We are the one adding this to the diagram. The question only talk about this. So we need to know what the L and this H is before we can be able to apply the formula. And if we check from here all the way to this place is the L. And if I cut off this as a triangle, I'll be forming this, with this side being 2, the radius being 6, here being the slant height of the smaller cone, then the L capital being the slant height of the bigger cone. I believe the concept is clear. Let's build into it. So from here, that is from the triangle ABC, using similarities and the corresponding size, I want to find the value. This is going to be H. So let's deal with the H first. So I am going to have the H is of the smaller triangle, right? So H divided by what is the bigger length. The bigger length from here to here as the height will be H plus 10. Then the smaller triangle will also have horizontal line of 2 divided by the bigger triangle of a horizontal line 6. Right? We can see the only unknown variable here is the H. So I can find the H of the cut off cone easily. This times this will give us 6H equals to 2H plus 10, right? So this is going to be 6H, 2H, 20. I guess so. Let's group like them. This guy will come here. 6H, 2H, 20. I guess you get 4H, right? So 4H equals to 20 by 4 by 4. H will be 5 centimeters. So we know the height of the cone that has been cut off. Very simple, right? Good. Now, since we know the height that has been cut off, we can find the slant height using this figure 2, Pythagoras theorem. So from figure 2, we can say that L will be equals to the square root of H squared, which is 5 squared plus what? 2 squared. This is the hypotenuse, equals to the sum of these two, the square root of that. So L will be equals to the root of 25 plus 4, right? So the root of, is that not 29? Good. On our calculator, root 29 give us 5.39. So we have 5.39 centimeter. So let's see what we can do from here. We know the various parts that we are looking for. We know the longer side, this very one. Okay, we can still find the slant height of the bigger cone using the same thing. So from triangle ABC, we can still have, what are we going to use? Let's use the smaller triangle first, which has the horizontal to be 2 divided by the other horizontal, which will be 6 of the bigger one. So we are going to have L divided by the longer one, right? Good. I guess you follow. Horizontal of the smaller one divided by the horizontal of the larger one equals to the slant height of the smaller one divided by the slant height of the larger one. What are we looking for? Capital L. We already know the small l. So we only have 2 capital 6L. So we are going to have L equals to, I think we could even have it. Okay, let's take it like that. So this will be 6 divided by 3L. I think it will be 2, right? So that will be 3 times L, which is 5.39. And 5.39 times 3 will give us 16.17 centimeter. So all the dimensions of what we introduced is being given to us. So the first thing we are going to do is to find the lateral area, which is the curved surface area. Now, to find the lateral area, we need the curved surface area of the bigger one. So, lateral area of bigger cone. What is the formula? Pi r L. The L is the length, which is the slant height of the bigger cone, which is going to be capital L. So 22 on 7, what is the radius? In this case, the bigger one take a capital R as a radius. Therefore, we are going for 6 times L, which is 16.17. And doing that on the calculator, that will give us 304.92, they say area, right? So centimeter squared. So that will be the curved surface area of the bigger one. Let's deal with the curved surface area of the smaller one. So lateral, let me use small abbreviation, curved surface area of smaller cone will also give us pi, okay, I think we can get a space there, pi r L. The R is the smaller radius here, the L is the smaller L here. So per substitution, 22 on 7, R is going to be 2. Your small L, where do we have it? It will be 5.39. Let's work that on our calculator and see. And that will be 33.88. So we can say that the lateral surface or lateral area of the truncated cone is going to be the area of the bigger one, which we had as 304.92 minus 33.88. That will give us our 271.04. We are talking of centimeter, right? So centimeter squared. You remember what we did using the formula from the previous episode? We arrived at the same answer. So that is, if we don't want to use a generalized formula, just find the curved surface area of the bigger one minus the smaller one, then you get what is left. Then that will also be done for the B. Total surface area of bigger cone. So the total surface area of the bigger cone, we know the bigger cone will be having a circular base, right? And that circular base will be area of the circle, that's pi r squared, plus the cross-sectional, the curved surface area, which will also be pi r l. Pi and r are common, so we have pi r divided by this r divided by this, we have l. So we can do substitution, picking the informations we have earlier on. So 22 on 7, r is the base radius, into bracket the base radius. The capital R, we had it to be 16.17. So let's put this in our calculator. We have 418.06 as area, so centimeter squared. So that is the total surface area of the complete cone. Now let's find the total surface area of the part that has been cut off. So from here, we are going to find total surface area of smaller cone. We know the smaller cone is just going to be a hollow cone. So we are going to have, let's say, pi r l. And that pi is 22. The r is the base radius, which is 2 centimeter. Then the L is what we have as 5.39. Putting that on our calculator, that will be 33.88 centimeters squared. Now let's look at this. If I add this to it, and it is taken away, you know that here there will be no circle because we are taking it away. But this is a complete cone. How do you call it? Truncated. This one has a base. This one also has a base. But when we remove this, you will still be having a cover here. This area and this one. To make it a solid truncated cone, we need to add back the upper area. The area that we have at the top. That is not added to this. So in that case, we are going to find the area of the top, let me say top base, okay? That will be pi r squared, 22 on 7, times r, which is what? 2 times 2, and that will give us 12.57 centimeter. So all that we are doing, we are looking for the total surface area of the truncated, right? So of the truncated cone. The total surface area of the bigger one, where do we have it? 418.06 minus, if you like, we add this one to it, because it is going to be the bigger one plus the top. It is going to be in that order. Or let's do a subtraction this way. Then minus the smaller one, which is 33.88. Then we add our 12.57. So this will be, and that will give us 396.75 centimeter squared. Just like we did, or we got, when we use the direct formula. If you use the direct formula, you arrive at this. The only trick or twist to all that we are doing is the addition of the base, the upper base or the top base to what we are doing already. All right. The last one will be the volume of the truncated base. Now, the last one is volume of the truncated will be the volume of bigger cone. How do you find the volume? We know 1/3 pi r squared h. But in this case, the bigger cone will have the base to be capital R. The height, this is h. This is 10. You remember? So the height of the whole cone will be h plus 10. What do we get for the h? 15. So that is going to be 15 for capital H. So if you substitute 1 on 3, 22, 6 times 6 times 15. And when you put that on your calculator, that will give us 565.71 volume, so centimeter cube. Let's go for the volume of smaller cone, which will also be 1 on 3 pi r square h, where the r is the smaller one, the h is the smaller one. So 1/3, 22 on 7. The smaller r is 2 square, the h is 5. So when you put all this in your calculator, that will be giving us 20.95 centimeter cube. So therefore, the volume of the truncated cone will become the volume of the bigger one, which we had as 565.71 centimeter cube, minus the smaller one to be 20.95 all to the centimeter cube. So let's see what we can get if we subtract that value. We are going to have 544.78 centimeter cube. All right. I guess you followed through from the beginning. If you don't want to remember the formula, this is what we are going to be doing in order to arrive at the solution. Check the first episode, that is part 4A, and see how that question has been solved using the formula. If you are conversant with that, then you are good to go. But we can also go this way. If you can't remember the generalized formula, we can take it step by step to arrive at where we are. I guess you follow? Like, share, and comment. Share this video with somebody who may need this tutorial on your contact list. And God will bless you. Bye-bye.